I'm going to be doing 3.15, and the question that's being asked is, vetiver, a soothing oil popular in aromatherapy, contains beta-vetivanone, hopefully I said that right, which can be viewed as a derivative of compound A. When they're asking, what is the name of this compound right here? And so, if we were to count the amount of carbons here along this carbon chain, you can start off here. So, 1, 2. Okay, and the reason why we're counting it like this, because we're going in a spiral fashion, where we're going from a cyclic molecule that is one carbon less than, in this case, cyclohexane. So cyclopentane is lower than cyclohexane, because it has one less carbon and so forth. And so if we were to name this compound, we'll find that it's, since we have in the 2 position, since we call this group an isopropyl group, like such, because we have 2 CH3s here and a CH over here. So in the 2 position, we'll go with 2 isopropyl. And then in the 6 and 10 positions, we have 2 methyl groups. So we'll do dimethyl. And then, like I said, since this is arranged in a spiro fashion, it's dimethyl spiro. Spiro 4, 5, because in the 4 and 5th positions, those are the positions where the spiro counting per se goes along. That's where we get, that's why, we count from the cyclopentane all the way down to the cyclohexane. And then we have dimethyl spiro 4, 5, and decane, just because there's 10 carbons, which results to 10 carbons, which results in a decane. And this is the lovely name for this beauty right here. And now if we move on to 3.18, the next question is asking, is geosmin, whatever it is a natural product that smells like dirt. It is produced by several microorganisms and can be obtained from beet extracts. So it says, complete the following decane ring skeleton, placing substituents of geosmin in proper orientation. So from this regular cyclohexyl form of the pheromone, using the chair diagrams, we need to arrange it properly. So just looking at it like this, using the chair forms, it looks like we have a methyl and a hydroxyl group like right dead center between the 2. So the chair form we're going to have like this. Not with the stereochemistry per se, but just since we're in a chair form, stereochemistry is assumed. So we have a methyl going like this, and a hydrogen like this. So this methyl is up with respect to this hydrogen. Well, actually, no, not hydrogen, because there's 4 bonds. So otherwise, you have to touch this carbon. Don't want that, do we? And then we'll have a hydroxyl group like this. And since the methyl and the hydroxyl group are arranged in a trans fashion, it explains why in this case, this methyl is going to be up or like above the cyclohexanes in the chair formation, and the hydroxyl group is going to be down with respect to the cyclohexanes. And so, with this last methyl right here, we can assume that this is down per se, since we already said that this methyl is up and this hydroxyl group is down with respect to the cyclohexanes. So, from what we counted, since there's 1, 2, 3, 4, 1, 2, 3, 4, with respect to, since we don't count carbons here in the middle, we can say that for the first position over here, corresponding to that, we have a methyl group right here and a hydrogen sticking up. It's kind of hard to tell, but this hydrogen is up and while this methyl group is down. So this methyl group is down with respect to this hydrogen right here on the cyclohexane. So this is up right here and that is down based on what they gave us on this structure right here. And this is what it looks like.